Good day everyone. By the way, I am Kerry Perez from Section Tribe of Simeon. And this is all about activity number 4 with the title of Mathematical Proofs and Steps in Problem Solving with the theme of Understand the Problem and Problem Solving Strategies to Mathematics in the Modern World. And this is Group Conceptual Framework. Group Objectives. We aim to teach all students about proof or mathematical proof and guide their understanding of how to use it. To share with everyone about the mathematical proof and how it is performed or solved to influence all students to increase their mathematical knowledge. For all students to understand more about the steps in problem solving. To be shared with all students from different sectors about learning using steps in problem solving. Introductions. In this discussion, students propose to share the two types that are discussed in the use of mathematics titled Mathematical Proofs and Steps in Problem Solving, which belong to mathematics in the modern world. Also, one of the discussions is about POLIAS, which is steps in problem solving that one of the students' requirements is to learn more by solving such as plans and look back. Mathematics is valuable, tested for problem solving ability and the ability to analyze a problem. Pick out the good heuristic from a large set of possibilities and chain them together to produce an answer.
What is mathematical proof? A mathematical proof is an empirical argument for a mathematical statement, showing that a stated assumption logically guarantees the conclusion. Mathematical proofs. A proof is a sequence of true facts placed in a logical order, including the following may be used as a reason: the given information, definition, and undefined terms, such as algebraic properties, postulates of geometry, previously proven geometric conjectures. Algebraic and geometric proofs. In order for us to prove properly and correctly, it is wise to remember and understand the necessary properties to be used in writing formal proofs.
What are the importance of properties of algebra? The importance of properties of algebra, it allows us to solve the equations. What is commutative properties? A commutative property states that if the position of integers are moved around, or the answer remains the same. For example, x plus y is equals x plus y, where x and y are any two whole numbers. Question number 2. yz is equals zy, where y and z are any two non-zero whole number. What is associative properties? The associative properties state that the multiplication and addition of numbers can be done irrespective of how they are grouped. For example, number 1, x plus y plus z is equals z plus y equals z. So x plus y plus z is the same expression with the term y and z grouped. X plus y plus z, this is the same expression with terms x plus y is grouped.
Addition properties of equality, or APE, is defined as when you add the same amount to both sides of an equation with two expressions that are equal to one another, the equation will remain the same. Let's take a look at this simple numeric equation. If 4 plus 6 is equal to 10, then 4 plus 6 plus 5 is equal to 10 plus 5, since each expression is equal to 15. You can see that adding 5 to each side of the original equation resulted in a true equation. The equation is still balanced. Multiplication properties of equality, or MPE. The multiplication property of equality states that when we multiply both sides of an equation by the same number, the two sides remain equal. For example, x divided by 6 is equal to 5. Multiply both sides by 6 and you'll get the value of x is equal to 30. To check, we can substitute the value of x in the original equation, wherein 30 divided by 6 is equal to 5, so the answer is 5 is equal to 5. What is a geometric properties? Geometric properties are those that can be derived from the geometry of a solid body or particle. They are very important as a means by which the size and shape of an irregular shaped particle can be easily quantified.
What is reflexive property, symmetric property, transitive property, and additional property of equality? So first, reflexive property of equality states that a number is always equal to itself. Reflexive property of equality, if A is a number, then A equals A, and A equals A, given AB is congruent to CD. Statement, AB is congruent to AB, and CD is congruent to CD. The symmetric property, it is the states that for all real numbers x and y, if x equals to y, then y equals to x. Given, AB is congruent to CD. Statement, CD is congruent to AB. The next one is the transitive property. Transitive property states that for all real numbers x, y, and z, if x equals to y and y equals to z, then x equals to z. And the last one is additional property of equality, or APE. If two expressions are equal to each other and you add the same value to both sides of the equation will remain equal. When you solve an equation, you find the value of the variable that makes the equation true. In order to solve the equation, you isolate the variable. Given 1, AB is congruent to CD. Statement 1, AB positive negative EF equals CD positive negative EF. Given 2, AB equals CD, EF equals GH. Statement. AB positive negative EF equals CD positive negative GH.
Definition of congruent segments, definition of betweenness, definition of midpoint, and how to write proof. Now let's start with definition of congruent segments, DOCS. Given number 1, AB is congruent to CD. Statement number 1, AB is equals to CD. Given number 2, AB is equals to CD. Statement number 2, AB is congruent to CD. Now let's move to definition of betweenness. DOB. Given statement AB plus BC equals AC. Next, definition of midpoint DOM. Given M is the midpoint of AB. Statement AM is congruent to MB. Now let's know on how to write proof. There are many ways on how to write proofs. We can have top-down or deductive reasoning or bottom-up or inductive reasoning. It can be formal or informal procedure. Example, prove the following using formal proof. Given Y is the midpoint of XZ. YZ is congruent to AB. Prove XY is congruent to AB. Statements and reason. Statement number 1. Y is the midpoint of XZ. Reason given. Statement number 2. XY is congruent to YZ. Reason, definition of midpoint DOM. Statement number 3. YZ is congruent to AB. Reason given. Statement number 4. XY is congruent to AB. Reason transitive.
George Polya. He was regarded as the father of the problem emphasized in math education and problem solving, and he has had an important influence on problem solving in mathematics education. He stated that the good problem solvers tend to forget the details and tend to focus on the structures of the problem, while poor problem solvers focus on the opposite. He decides that the following in 4 steps process such as understand the problem, devise a plan, carry out plan, and look back.
What is mathematical problems involving patterns? In mathematical, we have a problem to solve. Patterns help us in many ways to solve problems fast and verifies the answer right away. It is also an important element in every mathematical curriculum, but some pattern needs enough time to understood. Pattern serves as a guide to solve problems. Patterns recognition in problem solving is the key to determine appropriate solution to problems and knowing how to solve certain types of problems. For example, find the next term of sequence. By understanding this problem, we are able to solve this problem. So we are required to find the next number of the sequence. Number 2, find the next term 1, 5, 12, 22, 35. So by understanding the problem, the given is 1, 5, 12, 22, and 35. So we are required to find the next number of the sequence.
Number 2, devise a plan. First term, 7 over 2. Second term, 19 over 2 equals 7 over 2 plus 6. Third term, 31 over 2 equals 19 over 2 plus 6. Fourth term, 43 over 2 equals 31 over 2 plus 6. Fifth term, 55 over 2 equals 43 over 2 plus 6. Number 3, carry out the plan. Sequence 7 over 2, 19 over 2, 31 over 2, 43 over 2, 55 over 2. There is a common difference of 6. 6, 6, 6, 6. Therefore, 6 equals 12 over 2. So, the next number in the sequence is 55 over 2 plus 12 over 2 equals 67 over 2. And the last one, number 4, look back. Answer, 7 over 2, 19 over 2, 31 over 2, 43 over 2, 55 over 2, and 67 over 2.
Recreational mathematics is mathematics done for recreation or as a hobby which is intended to be fun. Typically, it involves games or puzzles that relate to the mathematics, although the term can cover other material. And these are the examples. 1 is equal to 4 divided by 4 plus 4 minus 4. 44 plus 44 is equal to 88. 4 divided by 4 plus 4 plus 4 is equal to 18. 44 minus 4 divided by 4 is equal to 6. In this example, 4 is used in 4 times to get a number.
Example number 2, the magic square. A magic square is an arrangement of numbers in a square such that all rows, all columns, and both main diagonals sum to the same number. A number referred to as the magic constant. The square on the right is perhaps the best known example of a magic square. Magic squares are very well known mathematical recreation like this image. That is example number 2.
Example 3. An elimination boxing tournament was organized. There were 114 participants, and so there were 57 matches in the first round of the tournament. In the second round, 57 winners as qualifiers remaining were paired, resulting in 28 matches. One qualifier fighter received a bye. The 29 qualifier fighters remaining were then paired, and so on. Questions. How many matches in all were required to determine a winner of the tournament? How many matches would be required if n people participated in the tournament to declare a winner? The answer of question A. From the matches from first round to the last round, 57 plus 28 plus 14 plus 7 plus 4 plus 2 plus 1 equals 113. 113 matches to be held all in all to declare one winner in the tournament. Or to eliminate 113 qualifiers, we need to have 113 matches where 113 equals 114 minus 1. The answer of question B. Using this information, we can deduct the winner that we need and 1 fighters to be eliminated and 1 matches will be required.